Hi, dear friends and students. Myself, Dr. VI Sem, Department of Mathematics, Kaylee Societies, Basaprabhu Kore, Arts, Science and Commerce College, Chikkodi. So here today we are discussing about calculation of residues. So in this concept, we shall concentrate on the first theorem. So first theorem states that if f of z has a simple pole at z is equals to a, then prove that residue of f of a is equals to limit z tends to a, z minus a into f of z. We need to prove that. So by seeing the statement of theorem first, we can easily get that if there exists a limit, right, and it is equals to the residues, right? So here there exists a limit and it is equals to the residues, and also it has converse part. So what is that converse part? Let us see. If the limit exists, then either the pole is simple or f is analytic at z0, right? F is analytic means f is differentiable, right? So proof of this theorem: directly from Lorentz theorem we can say that f of z is equals to summation over n is equals to 0 to infinity an into z minus a whole raised to n plus summation over n equals to 1 to infinity a subscript minus n z minus a whole raised to minus 1. So using this equation we can express it as a0 plus a1 into z minus a plus a2 into z minus a whole square, so on plus a subscript minus 1 into z minus a whole raised to minus 1. So this implies f of z is equals to a0 plus a1 into z minus a plus a2 into z minus a whole square plus so on plus a subscript minus 1. So here z minus a whole raised to minus 1 is there, so it can be written as 1 divided by z minus a. So multiplying throughout the equation f of z, this equation with z minus a, we get z minus a into f of z is equals to, so right side part of equality will be like this. So at last 1 divided by z minus a into z minus a are get cancelled. So taking limit as z tends to a, we get limit as z tends to a, z minus a into f of z is equals to limit z tends to a, this quantity a0 into z minus a plus a1 into z minus a whole square plus so on. The last term will remains a subscript minus 1. So if you apply the limit through this equation, will remains with a subscript minus 1 because this quantity will be 0. So if you put z is equals to a, this quantity will be 0. So therefore all these terms up to this term are 0. Only will remains with a subscript minus 1. So this a subscript minus 1, we can say that residue of f of a. So therefore residue of f of a is equals to limit as z tends to a, z minus a into f of z. So this completes the proof of first theorem.